All right, so let's take a look at this problem. It's from scale 3A, interval and set builder notation. We have a number line, and there are parts of the number line that have been shaded in representing sets of numbers. We want to describe this set of numbers in part A using interval notation and in part B using set builder notation. So with interval notation, on the left hand, we always start with a smaller value, so always start on the left of the number line. -7 is an endpoint. It's a solid dot, so we need a bracket, and then the number -7, and then comma, and it goes all the way to this endpoint, -2. But -2 is hollow. It's excluded from this set of numbers, and that's represented by a parenthesis. So either you're in this interval or you have values that are of interest in this interval. So with the word or, we need a mathematical symbol, a union for it. We go small number, comma, larger number, 3, that's shaded in. We include 3 in this set, so we want a bracket. And numbers from 3 all the way to 6, but we exclude 6, so we have a parenthesis. So there, this describes the shaded set of numbers on that number line using interval notation. With set builder notation, you're always going to have these braces. It's always going to have a variable. For us, it's always going to be x. This vertical line is read such that, so we have the set of all x such that, and now we're going to write our compound inequalities. This first range of numbers here, I always like to start on the smallest endpoint, -7, and I need to determine my inequality here. Since that's a smaller number, and inequalities, the arrows point to the smaller numbers, it's pointing to -7 is less than. Since I'm including that, it's less than or equal to, and it's the variable of interest that I've called x. And this endpoint is not included in this set of numbers, so it's strictly -7 is less than or equal to x, which is strictly less than -2. That describes that. Now I need another union symbol because I'm either interested in this interval of numbers or the second shaded interval of numbers, and I can write it as 3 is less than or equal to, because it's included in the set, for x strictly less than 6. Now if you wanted to, you could write the same answer. I always like to have less thans and to write it like this because it matches up with the number line, but you could have -2 is strictly greater than x, which is greater than or equal to -7, and 6 is greater than x, which is greater than or equal to 3. So notice in my inequalities, in this first answer here, the arrows all point, well, within this, the arrows are pointing in the same direction. Here to the left, the arrows are pointing in the same direction to the left, and it's pointing to the smaller value. -7 is smaller than -2, 3 is smaller than 6. Here the arrows are pointing in the same direction, and they're also pointing at the smaller value. -7 is less than -2, 3 is less than 6. These are logically equivalent. I usually use the explanation of if I have somebody that's 5 feet tall in the classroom, a student, and then me, I'm almost 6'3", I am taller than that student, or you could say that student is shorter than Mr. Unsinger. So it's just whether you're saying x is bigger than 5 or that 5 is smaller than x. They are logically equivalent. So I hope that helps, and let's see what the next problem is. Let's go ahead and do this one on the same video. To determine the domain and range of a relation is a set of ordered pairs, and so the order is important. We call the first number of each pair the x-coordinate, and the second number of each pair the y-coordinate. The domain is the collection of x's. Here we have a finite set, a finite collection. So we just list the numbers. You just don't list, once you're in the set, you don't list a number twice. We see that -8 here is twice, but in the domain I'm only going to list it once. So So I've got -8, and then I just usually, you can write it in any order. I just write it in the order that it appears. -8, comma, -5, 0, 2, and do not write -8 again. For the range, it's the set of y values from each pair, and we see that 6 is repeated, but we never write that repeated value in our set note in our set. So we've got 6, 0. I've already listed 6, 3, and 5 as members of the range for this relation. Hope that helps. Talk to you later.